Welcome back to part 2 of our live training session here with our K24 swapped Civic Si. Now in this tutorial we're going to continue with the base map creation process and then populate our fuel and spark timing tables, variable cam control tables, engine safety features, all kinds of additional information that we need to make sure is right so that when we fire up our engine we're going to have a solid base map. Let's jump in here and continue on with our base map creation. Welcome back to our live training session here with our K24 swapped Civic Si. The last tutorial, we started our base map calibration process. We set up the inputs and outputs and set up the basic configuration details. This tutorial, we're going to complete the base map calibration process by going in and setting up all of the fuel tables, spark timing tables, variable cam control tables, and anything else that's going to be associated to properly dialing in our engine. Let's jump right into the tutorial here. I have my laptop connected to the link. The vehicle here is powered on, engine's not running, so key on, engine off. We can see right now, we can see the data here streaming live. We're going to just go through all the tables here in the tutorial and build everything out. Let's first jump into our fuel table. It's the very first table I'm going to start to work with. So I'm going to move from my basics page here over into my fuel specific tab. Now, the layout that I'm working with here is available in the training course folder, so you're able to download that along with a lot of other great information that's very useful for working with your G4x system. We're going to be taking a look at importing a lot of table data here, making the base map creation process incredibly simple. All of this information, including the layout that we're working with here, again, is available right into your training course folder. Make sure you download that, and if you're having trouble with it, definitely let me know in the comments section. I can get you set up with that folder if you're having problems obtaining it on the website. So let's jump in here and take a look at our fuel specific page. Now in here we have our main fuel table. This needs to be set up for a naturally aspirated engine. Since we have just basic bolt-ons, we're not forced induction, we need to configure this. This fuel table 1 here, will be our low cam of operation, so non-VTEC. We're going to actually set up another table and another window for fuel table 2 associated to high cam or VTEC operation. And this is going to give us the ability to characterize the fueling for low cam and high cam. There's a completely different amount of fuel delivery needed for low cam versus high cam. There's a completely different amount of airflow low cam versus high cam. So VTEC is very unique with the 2 different profiles built onto one camshaft grind. We need to go and make sure we're following essentially what Honda's created in the factory mapping and the factory computer control. So that's exactly what we're going to do here. This table is going to be associated to low cam operation. What we're going to do here is actually use our import function and import a table that's going to get us started that's for a naturally aspirated engine. What I'm going to do here is right click and go here to import and go into import from file. We're going to take a look here and we're going to specifically look for our fuel table, VE table here. And we can see here we have a fuel table 1 naturally aspirated engine. So we're going to use this option. When we choose this, it's going to be setting our MGP manifold gauge pressure from 0, which is going to be atmospheric pressure, all the way down to -100, which is full vacuum. And this is going to be spanning here from 0 to all the way out to 9,000 RPM. Now we're not going to see 9,000 RPM on our low cam, but we're going to allow it to go out and span that full width of the table. So we have this table populated with values that are good starting points. We are in the model multi-fuel mode. This is going to allow us in this model multi-fuel mode to have the VE values here expressed as a percentage of cylinder filling. So these should be a pretty reasonable starting point. And we'll have to see when we get the engine to fire off if we need to adjust these. They're very likely we're going to have to be adjusted, and we'll go through that process when we get to that point again in the next tutorial. We need to have something as a starting point, and this is an excellent starting point. The next thing we need to consider is our target lambda target air fuel table, what we want to have for a desired target air fuel. So this is establishing our air mass. This is establishing our target air fuel. If we know the air mass, we divide it by the target lambda target air fuel. That's going to give us a fuel mass. We can convert the fuel mass into an injector pulse with knowing the injector flow and injector dead time values. So that's how the basic fuel and airflow modeling works within the link. So we need to specify this target air fuel. And what we'll do here again is we're going to use the import function. You're probably going to see how useful this function is going to be. I've been using it heavily in the last year. If we go in here to our lambda, so let's look here in our control. Going through all of our different windows here, closed loop fuel control, and we're going to go our target air fuel. So air fuel lambda target. We'll go ahead and grab that. And now we're going to populate this. Now this table here is set up for a turbo engine or supercharged engine. It's going from 0 to 200 kPa in our manifold pressure. What we're going to do is actually tweak this a little bit. I'm going to go here and click on the axes and click X, and then it's going to allow me to access the map pressure axes right here. I'm going to go and just change this up a little bit. I'm going to say the 0.4 here is 75. I'll do this one here at 90. I'll do this one here at 100. And then I'll do this one here at 120. It's fine. We'll just change this up a little bit, and we'll click OK here. Click yes. And when we're at here, 90 to 100, 90 to 120 kPa, we're going to change all of our values here to 0.86 lambda. And then as we're approaching and going between 75 to 90, that'll drop it from 1.0 lambda stoichiometric down to a richer target mixture. And then at our higher engine range right here, so 6,000 and above, we're going to be targeting 0.9 lambda. We're going to richen up that mixture a little bit. That way we have good part throttle response, a little bit better fueling when we're at high RPM, and then we transition right into our full throttle, essentially 90 to 120 right here. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.